All right, class, you should have had some time to have worked on this adding and subtracting polynomials. Basically, we are combining like terms. So here's the answer to number 1, 7x. Here's the answer to 2, negative 3x. The answer to 3, 4y plus 13. The answer to 4, 4y minus 1. Answer to 5, 7x squared. Answer to 6, 5x squared plus 5x. Notice I have an x squared and an x, so I have two different terms. That's why I can't combine all three. 7, 10x plus 10y. 8, negative 3x squared plus 2x squared. 9, I have to use the distributive property. I have to distribute the negative 2. You get negative 2x, and what is a negative times a negative? It's a positive. Good job. 10, negative x plus 5. Again, distribute that negative. Negative times a negative becomes a positive. 11, 2x plus 10. I have to distribute the negative 2 first before I combine my two like terms. Same idea in 12, 3x plus 5. It's a big one, right? X cubed plus 5x squared plus 3x. And number 14, 3x squared plus 10. Why is it plus 10? Because this negative has to distribute. Negative, negative becomes a positive 4. What's 6 and a positive 4? You got it, 10. And 15 is 2y cubed plus 6y squared minus 5. And 16y minus 2. Again, you can rewind this video if you need to see any of the answers again. Right now, you should get the probability and percent notes, which look like this. We're going to start on this today. All right. So pause the video and get these distributed out, and we'll begin. All right, you and your friends, they are enrolled in two different sections of AFDA. You both took midterm exams, and the test scores were normally distributed. In your section, the mean was 80, and the standard deviation was 6.7. And your score was an 82. In your friends section, the mean was 71, standard deviation was 6.1, and her score was 83. Notice there are two pieces of information in here. One is for you and your class, which is in blue, and the other is for your friend's class, which is in red. So there's a lot of information packed into this paragraph, but here is the key information. All right, what I want you to do on problem A and B is I want you to draw the curve and do the shading. Go ahead and take a minute, pause the video, draw the curve, and do the shading in A and B. All right, now that we have drawn the curve and done the shading, which I haven't done yet, so let's do real quick. So the curve for this one, what goes in the middle? Shout it out. The mean. And what is the mean from my class or your class? Well, the mean is 80. And I need to go up and down by 3s. So what am I going to add to 80? Good, the standard deviation, which is 6.7. So I'm going to get 86.7. Add 6.7 again, and I get 93.4. And one more time, and I get 100.1. Hopefully I did my math correct. And now I have to subtract the 6.7. So I get a 73.3. Subtract 6.7 again, and I get a 66.6. And one final time, I get 59.9. All right. What percent of your math class scored between an 85 and a 90? So, between an 85 and a 90. So 85, this is more than 80 but less than 86. And 90 is going to be roughly in here. And I want to know what's between, so I'm going to shade in the middle. Remember, we use our norm CDF to get the probability. So, second vars, normal CDF. Lower is 85, upper is 90, mean is 80, and standard deviation is 6.7. So what's my probability? 0.16. 0.16. If I want 4 decimal places, this 7 rounds the 9, but since this is a 9, it rounds this, which rounds this, so we just get 0.16. Now, remember, it also asks, again, what's the percent? So it wants both this time. How do I convert this to percent? Multiply it by 100, and I get 16%. So here are my 2 answers. All right, so on B, we want to go above a 90, right? So here, we have to draw our curve, and we put the mean in the middle, and the mean was 71. And I'm going to go up and down by the standard deviation, which was 6.1. So if I go up by 1 standard deviation, 77.1, add 6.1 again, 83.2, and add 6.1 again, and I get 89.3. And then subtract the 6.1 to go below. And we get 64.9, and we get 58.8, and we get 52.7. All right, and I want to know what's above a 90. Well, if I look right here, above a 90, that's even past the 3rd standard deviation. So, and I want to go above, which is over here. So I'm going to think it's not a lot. And I want, again, probability and the percent. So you're going to take what the calculator gives me and turn that into a percent, just as we did above. So you go back to second vars, CDF. Lower is 90, but since I shaded to the right, I want a really big number, 99999. The mean was 71 and standard deviation 6.1. Whew, what's this e to the negative 4 deal? So this is just how the calculator does scientific notation. This negative 4 means take this decimal 4 places to the left. So here's 1. I'm going to need 3 more zeros. 1, 2, 3, 9. Right? So the decimal was here right after the 9, and I moved it 4 places to the left. 1, 2, 3, 4. Now I have it in terms of the probability. I want to take that to a percent, multiply it by 100. And I get 0.09. Added 1 too many. Percent. All right, so the area under the curve, what we've been shading, is a graphical representation for probability and percent, depending on how you want to look at it, probability and percent. So now we're going to talk about percentiles. A percentile is a percent of X values that are less than the given X score. So less, I'm always looking to the left of the X value. So, an example, on an SAT score, if you're in the 80th percentile, that means that 80% of students scored less than you. So if X is 85 and it represents the 90th percentile on a test, that means 90% of the test values are smaller than 85. So in this picture, if you want to think about it in terms of the curve, the mean is here. 90% is way above the mean. So over here somewhere we have an X value of 85. And this area in here is 90%. So this one score is bigger than 90% of the values. All right, let's move on. Let's do a problem. All right, a student received an 84 on the midterm. So the 84 is like the X value. The mean on the test was an 82, and a standard deviation of 1.5. So I want to find the percentile. So the big idea is I want to use the calculator to get the probability and turn that into a percent. So here's kind of the key. The percentile is the percent of students who received less. Remember, when we shade on the curve, less is always to the left. All right, so let's go ahead and draw our picture. Put the mean in the middle. The mean was an 82. You go up and down by standard deviations. So 82 plus 1.5 is 83.5. Plus another 1.5 is 85, and then 86.5. Take away a 1.5, I get an 80.5. Then I get a 79, then I get a 77.5. All right, and I want to know what the percentile is. So my X value was 84, so 84 is right in here. And remember, when I'm finding percentiles, which way do I shade? To the left. To the left. So which way do I shade? To the left. Say it again. Which way do you shade for a percentile? Left. Good. So we're going to do our shading to the left. And then now we can see what we were doing yesterday. We can use our lower, upper, mean, and standard deviation. This time the lower is my negative 99999 because it never stops and it keeps going to the left. Upper, it's again, and I say this over and over, that's why I like the picture. You see right where we stop, which is 84. The mean is an 82 and standard deviation is 1.5. So come back to our calculator. Second VARS, normal CDF, negative 99999. 84, 82, 1.5. These are, we're just putting these values in. So I get 0.9088. This 8 rounds to 7. Now, what does it ask? It asks for the percentile. So here is a probability. This is a probability. I want a percent. So this is, taking this to a percent is 90.88%, But we're going to leave our percentiles as whole numbers, no decimals. So we need to round this. So we are in the 91st percentile. And here is our final answer, the 91st percentile. All right. Let's jump down here. And again, if you need to pause this at any point, feel free to pause. Another student in your class received a 75 on a test with a mean of 80 and a standard deviation of 5. Oh, well, this one's really nice. So let's draw our curve. With a mean of 80, right? Mean of 80, and what's my standard deviation? Well, it's 5. So I'm going to go up by 5s, down. I love counting by 5s. It's way easy for my head to do. 85, 90, 95, 75, 70, 65. What's nice with this one is the student in the class got a grade of 75. Well, where is 75? It is on a nice standard deviation. I like it. So remember, if I'm finding a percentile, which way do we shade? Everyone? To the left. Good. So shade to the left. And since it's on a nice line, I actually know these percentages already. This is 13.5, 2.35, 0.15. What do I get if I do 13.5 plus 2.35 plus 0.15? 16%. Good. And I'm in my this is already a whole number, so we are in the 16th percentile. Good. Again, pause this as needed. All right, jumping down here. We're almost finished with this side. All right, refer to the example 1. So what we're going to see who did better relative to the class. So I want to find your percentile, your friend's percentile, and then based on those two values, say who did better. Right? Well, so what was your grade, the X value? It was, anybody shout it out? 92. Good. And then draw our curve. So what was the mean of your class? It was an 80. So 92, I'm going to go ahead and do it quick. 92 is going to be above 80 somewhere. So X equals 92. Which way are we going to shade? Well, it's a percentile. Percentile you shade to the left. Shade to the left. So can we very easy see what our lower, upper, mean, and standard deviation is? Well, what's my lower? Well, since it keeps going to the left, I need a really small number, so a negative with a bunch of 9s. My upper, that's why I like the picture, is 92. What's the mean? 80. Standard deviation, 6.1. So go back to our calculator. CDF, negative 99999, 92, 80, and 6.1. Now, this is the probability. So I get a probability of 0.9754. But I want that as a percent, because I'm taking to a percentile, so 97.54%. But we like percentiles in nice whole numbers, so we're going to say the 98th percentile. We're going to round it. 98th percentile. And you couldn't see any of that. But now you can. There we go. All right. What I want you to do is take a couple minutes, find the percentile of B, and say who did better based on their percentile. Go ahead and pause the video. All right, now that you've had time to answer these, I'm going to say you probably should get the 90, well, let's see. Let's go ahead and use this one real quick. So you should have negative 99999, and the upper being 83, the mean being 71, and standard deviation being 6.1. All right. So we get the 98th percentile. So who did better? What do you guys think? Go ahead and shout out the answer. Well, it looks like they did the same. They both are in the same percentile. So again, if you have any questions, like just as yesterday, you can email me and I will be happy to answer any of these questions. Now, so you guys should have been yelling at me, which I hope you were, because I probably typed something wrong in example A, and since we're 22 minutes into this video, I didn't want to go back and redo it. The probability that the calculator actually gives you is 9634, which means this is not 97. This is 96.34, which means you're in the 96th percentile. 96th percentile. All right, I apologize for that. I don't know what happened. Hopefully somebody caught that and was yelling out and saying I did it wrong. If I did, if the sub could make a note of that, I will be happy to give some bonus points for that. So who did better based on the percentile? Your friend. Because she is in a higher percentile. All right. So, last page, guys. We're almost there. You guys are troopers. All right. So what we're going to do now is do a percent to an X score. So we're going to start with a percent, and we're going to actually find an X value. So what we're going to do is we're going to not even worry about talking about z-scores. We can cross this out. So let's kind of go ahead and work on example 1. All right. Here's what I want you to do. We're going to draw this picture, but the information is a little different this time, and we'll talk about why. So here, the mean grade on a midterm was 78. Standard deviation of 6.5. So I scored in the 80th percentile. What I want to know is what my grade is. So this percentile is really talking about the area under the curve. So 80% is somewhere right in here. When it be in the 80th percentile, that's this all the way over here. Do I know that X value? No, that is what I'm trying to find. My grade is the X. and I don't know that. So here we have to do a little something different. Instead of getting the percent or finding the percentile as what we did on the class period before, this is kind of going backwards. So we have to remember a new keystroke. Second, bars, same place, but this time, if you look right under CDF, it says 3, and I want INV norm, inverse norm. That's going to give you 3 options. It's going to say area, it's going to say the mean, and the standard deviation. Well, I know what the mean is, 78. I know what the standard deviation is, 6.5. But what's the area? And that is the key. The key is this 80%. What is 80%? What is 80% as a decimal? Shout it out. 0.8. This is the number that I'm going to plug in for my area. This is the number that is going to go into my area, 0.8. So let's actually put this in the calculator. So second vars, I'm at inverse norm. Notice it gives me area 0.8, mean is 78, standard deviation is 6.5. And it spits out a value. And the value is an X, 83.47. So what did I get? On the midterm, I got an 83.47. I passed with a B. Woo! All right. Let's do example 2. So let's draw these curves real quick. Won't take too long since we're shading an area region. And the mean was 85. So let's make our 2 curves that have a mean of 85. All right. So the 90th percentile. Well, I know that the 90th percentile is above the mean. So right in here is going to be 90%, and I want this. So again, what is 90% as a decimal? 0.9. So we're going to go back to inverse norm, where it says area, mean, and standard deviation. Area would be 0.9. The mean is going to be an 85. Standard deviation of 6. So let's crunch these numbers. Second vars, inverse norm, 0.9, 85, and 6. So my grade on a test was a 92.69. 92.69. All right, next one. We're talking about the 50th percentile. Well, the 50%, isn't that right in the middle? What's in the middle? The mean. So what did I get? This is a super easy one. What was my grade? If I'm in the 50th percentile, that means I did better than half the students, right? And this is a nice curve. What number's right in the middle? It's the mean. So I get 85. If you were to plug this into the calculator with the area, mean, and standard deviation, that is an acceptable way to do it, and this would be your answer. All right, what I want you to do now is work on example 3 and 4. Example 3 and 4. Go ahead and pause the video. All right, so going back to this. So you should get an area of 0.9 in the 90th percentile, mean of 500, standard deviation of 100. So this is the minimum SAT score, 628.16. I really like the next one here. It gives you two pieces of information, and it asks you to kind of think and put them both together. So it wants to know what the difference in the scores of the 90th percentile. So in state A, I found the score in the 90th percentile. State B found the score in the 90th percentile. But it asks for how do they differ? So what do I do with these two numbers? You subtract them. 594.85 minus 588.83, and you get 6.02. So go take a minute, look at this, and you can pause the video. All right, so the next thing you have in your packet is a probability and normal distribution review. I want you to go ahead and continue working on this. It should just be the next page in your packet. It kind of combines everything we've done in the past couple days. Guys, you're awesome. Keep it up.